All right, let's get right into it. Welcome to this explainer, where we're going to break down the true nuts and bolts mechanics of artificial intelligence. I mean, we see AI absolutely everywhere today, right? It's generating these breathtaking pieces of art, writing complex essays, driving our cars, and even diagnosing rare diseases. It's holding conversations that are honestly getting pretty tough to distinguish from a real human being. But to really grasp what is happening underneath the hood, we have to completely clear away the hype.
And that brings us to our first and frankly most important rule. AI is not magic. It's math. I know, despite the incredible, almost unbelievable things this technology can do, at its core it is fundamentally just a set of mathematical techniques. Now, they are incredibly sophisticated techniques, sure, and highly powerful, but ultimately they are completely understandable. Once you start viewing AI through the lens of mathematics rather than some kind of digital magic, the entire landscape just instantly becomes clear.
So for today's explainer, we are diving into a completely grounded, totally jargon-free report to strip away all that science fiction. We really want to look at what is actually happening behind the screen. Our goal here is to keep things clean, forward-looking, and rooted in total reality, so we can finally wrap our heads around the mechanics of this world-changing tech.
So here is our roadmap for today. 1. What AI actually is. 2. How AI learns patterns. 3. How language models work. 4. Real limitations and risks. And finally, 5. The future of AI.
Okay, starting off with Section 1, what AI actually is, and really demystifying the technology.
You know, we are constantly fed this Hollywood science fiction narrative where AI has a consciousness, deep human-like understanding, and, secret intentions. But the reality? It is completely different. Modern AI absolutely does not think the way you or I think. It has zero consciousness, no desires, no hidden agenda. What it actually does, and what it excels at way beyond human capability, is recognizing insanely complex patterns in massive data sets. It's entirely driven by statistical regularities. It's finding the hidden connections in data, not hiding a secret mind.
The actual engine behind this incredible pattern recognition is something called a neural network. It's loosely inspired by the biological architecture of our own brains, but really it's a mathematical system made up of layers of interconnected nodes. And the crucial mechanic here is that during its training phase, this network adjusts the mathematical weight of its connections just a tiny bit with every single new example it processes. Through sheer brute force repetition, it just gets incrementally better at producing the correct output.
Moving right along to Section 2, how AI learns patterns. Let's look at a very concrete example of an AI literally learning how to see.
Imagine we're teaching a brand new system to recognize a cat. Step 1, you show an untrained neural network a photograph clearly labeled cat. Now, because the network is totally untrained, Step 2 is pretty much guaranteed. Its guess will be wrong. But Step 3 is where the crucial math kicks in. The system calculates exactly how wrong its guess was, a really precise metric that programmers call the loss. Finally, in Step 4, it takes that loss calculation and adjusts its internal connections to make a slightly better guess the next time around.
This whole adjustment process, that is called backpropagation. The system tweaks every single connection slightly in a direction that makes the output less wrong. Before this concept came along, programmers actually had to manually write rules for everything, like literally trying to tell a computer exactly what a cat's whisker looks like. Backpropagation was a real game changer because it allowed machines to teach themselves. And here's the wild part. It does this millions of times, which takes immense computational power. But it figures out what whiskers, ears, and fur look like entirely on its own, purely through statistical regularities.
Which brings us to Section 3, how language models, and specifically stuff like ChatGPT, actually work.
The crazy thing is, the fundamental architecture doesn't actually change when we scale this whole concept up to language. Large language models, or LLMs, are essentially just giant neural networks. But instead of analyzing millions of photographs of cats, they digest absolutely enormous amounts of human text. We're talking entire libraries, wikis, and vast swaths of the open internet.
So this brings us to a fascinating question. Honestly, it's arguably the most important technological question of our decade. What exactly is an AI like ChatGPT doing when it naturally answers your prompt?
The answer is deceptively simple. Its only fundamental task is to predict the next word. That is literally it. It is essentially autocomplete on an astronomical scale.
But a really profound insight happens here. When a machine predicts the next word billions of times across billions of human examples, it actually inadvertently learns the structure of human knowledge. To accurately predict the next word in a super complex sentence about, say, quantum physics or a historical event, the model is mathematically forced to develop deep internal representations of facts, logic, and reasoning patterns.
But this next word prediction method has a really famous flaw, the hallucination. Because the AI is only guessing the most statistically likely next word based on patterns, it sometimes strings together sentences that sound incredibly confident but are entirely incorrect. The system isn't trying to deceive you, right? It has no concept of truth or lies. It's merely generating continuations of text that are mathematically plausible. Sometimes that plausibility is spot-on accurate, and sometimes, well, it's plausibly wrong.
Okay, Section 4. Real limitations and risks. Getting beyond the science fiction.
When we finally strip away the magic and realize it's just math, we see the real threats. The risks we should take seriously aren't rogue superintelligences plotting to take over the planet. They are much more mundane but highly critical dangers. Malicious misuse of the technology, the rapid concentration of power among a few massive tech companies, the steady erosion of our personal privacy, and algorithmic bias.
Consider bias for a second. AI learns from historical data, which means it simply reproduces our historical inequities. If a hiring algorithm is trained on decades of biased corporate hiring data, it's going to mathematically replicate those exact same biases when sorting resumes today. Now, look at the black box problem. This refers to the startling reality that even the brilliant engineers who build these massive neural networks cannot fully explain why the system produces a specific output. If we're deploying AI in high-stakes environments like legal sentencing or medical diagnoses, not knowing the why behind an answer is a massive societal hurdle.
And that leads us to our final section, Part 5, the future of AI and how it's shaping the world.
Look, despite those very real risks, the positive impact is already here, and it is mind-blowing. We are witnessing breakthroughs right now that were completely unimaginable a decade ago. In medicine, AI systems are currently matching and sometimes even exceeding specialist performance in reading complex radiology images and detecting early-stage cancers. Or take DeepMind's AlphaFold. It literally solved a 50-year-old grand challenge in biology regarding how proteins fold, and then they freely shared the structural map of nearly every known protein with researchers worldwide. That is absolutely accelerating the future of drug discovery.
I want to leave you with this powerful thought directly from our source material. The people who understand how it works, its capabilities and its limitations, are better positioned to use it effectively and participate meaningfully in the decisions societies will need to make about it. That is everyone, including you. Remember, AI isn't magic, it's math, and it is already making decisions that affect your life every single day. So, knowing what you know now, how will you choose to interact with the algorithm tomorrow? Thanks so much for watching this explainer.